935 maximum strong pair XOR II. So for this problem, we are given an array nums, and first of all, we have to meet such kind of formula. So the formula is x minus y. The absolute value of x minus y gonna be less than or equal to minimum of x and y. Yeah, so according to this one, how can we get a formula of this one? Because basically this one is difficult. If we use the brute force, it is okay. But the length of the nums is 10 to power of 4 basically. And we cannot use the brute force to solve it. Yeah. So what if we can just sort the nums? So for example, this nums is 1, 2, 3, 4, 5. If we can sort the nums, and then how can we simplify this formula? So this means if the x is the previous value and y is the current value, yeah. So according to the formula, and we can get 2 times x 2 times x gonna be more than and equal to y. So according to the formula, definitely we can get this kind of formula, but how can we get it? So first of all, we're gonna sort the nums array. So after sorting, the value of x gonna always be less than and equal to the value of y. Yeah, but in order to make it to this formula, let's just check. So x minus y absolute value gonna be y minus x, gonna equal to the minimum of x and y gonna equal to x. So this means y, yeah, because x is less than or equal to y, so y gonna equal to 2x. Yeah. So if we meet the conditions, basically, this means 2x gonna more than and equal to y. Yeah, I hope we can get this kind of formula. So this is y minus x gonna be less than or equal to x, and y gonna be less than or equal to 2x. So this is exactly how can we get the formula. Yeah. So y gonna less than or equal to 2x. 2x is gonna be more than and equal to y. So this is we can get this kind of formula, and this is easy. But how can we solve it less than O(n) squared time? We can use the property from Leetcode 421, and yeah, basically you can check my video for solving this problem. Basically, we used a hash table. We used a hash set to solve the problem. So the only difference is that for this problem, we're gonna use a hash table. Yeah, because here we have to find 2 values of x and y. But how can we find the 2 values? Yeah, we have to use a hash table. So here is the hash set. We cannot record the values, but if we use a hash table, definitely we can find those 2 values. And yeah, we just need to increase some checking for the hash table to solve the problem. Yeah. Yeah, so the basic idea is that we're gonna prepare a mask to solve the problem. Yeah. So from the beginning, the mask is always be 0, and then we're gonna set the mask to be 1. We're gonna always check the highest bit. So for example, if this 1 is the highest bit, yeah, and for this 1 is the highest bit, and this is mask, and then we're gonna check all other numbers. So for example, we have some numbers maybe 1 0 0 0 1, or maybe we have some numbers 0 1 1 1 0. Yeah. Now we want to check if we want to use the XOR operation, can we make this highest bit to be 1? Yes, it is possible. This 1 is 0, because we're gonna only consider this 1 is 0. Because if we use a mask, definitely we will ignore all those bits at the moment. So we will only consider this 1 is 0. Now it is possible, because 1 XOR 0 is gonna be 1. Yeah, so this means for the highest bits, we're gonna set a final result. It's gonna be 1. And then we're gonna continue to check the next one. So imagine we just have 2 numbers. It's gonna be like this. Yeah. And then what about the next mask? So the next mask gonna be here, and this 0 we're gonna set it to 1, and this gonna be the new mask. Now we're gonna check this bit. This bit is 1. Is it possible to make it 1? Oh yes, it is. This is 0 1. It is possible. Yeah. So this means for the next bit we're gonna set it 1. and then we're going to continue. This is 0 1 0 1 is possible. We're going to set it 1 1 1. So this means for the maximum number, it's going to be 1 1 1 1 1, and it's going to be 31. So this is going to be the maximum number for those two numbers. And then at the same time, we need to check if we meet the conditions of 2x going to be more than or equal to y. So which one is smaller? This one is smaller. So this is 8 plus 4 plus 2 is going to be 14. And this is let me think about it. This is 16. 16 plus 1 is going to be 17. So 2 times 14 going to be more than or equal to 17. This means it is okay. So 31 going to be the final answer. So this is exactly why we can solve it like that. Yeah, we're going to use a mask. The mask is going to, from the beginning, it's going to be something like this, 1 0 0 0, and then it's going to become 1 1 0 0, and then it's going to become 1 1 1 0 and 0, and then we're going to just try to check each of the bit. If it is possible, we're going to put a 1. If it is not possible, we're going to put a 0 until we find the final answer. But at the same time, we're going to use a hash table to check this formula. 2x is going to be more than or equal to y. If it meets the conditions, we're going to prepare the final result. Yeah, otherwise we're going to continue to check. Yeah, I think that's all about it. Now let's just start coding. The coding is going to be a little bit difficult because basically it is because basically if you are not familiar with Leetcode problem 421, and it's really difficult to understand this problem because they are used exactly the same strategy. Yeah, so I'm going to prepare a final result and a mask. And from beginning, I'm going to set it to 0. Now, I want to check the maximum number. So the maximum number for the nums are going to be 2 to the power of 20. Yeah, so this means for the range, I can set like 21. That is enough. Yeah, because this is the maximum number. It is 2 to the power of 20 minus 1. Yeah, so I think 20 is enough. 20 is enough, so I'm going to use 20 minus 1 and minus 1. And first of all, I'm going to update the mask. Mask gonna or a 1 left shift how many bits? It's going to be this I. And I'm going to prepare a temporary answer. And this answer going to be the result XOR 1 shift left shift I, 1 left shift I bit. Yeah. So now instead of preparing a set, we're gonna prepare a hash table, and we need to check the numbers one by one. So for n inside the nums, we're gonna update the new number. So I'm gonna use a new number, new n, gonna be a new number. So this new number gonna be n with a bitwise add with the mask. Now I want to check if this new number XOR XOR the answer. So basically for here, this is just like 2 sum. Leetcode problem 1. This is a 2 sum. If this new number, this n add a mask, just means we're gonna check the previous numbers. So for example, this 1 1 is gonna be the previous numbers. We just need to check the previous numbers. Maybe this 1 1, maybe here is 0 1, and 0 1 is our number. XOR 1 1, it's gonna be 0 1, and after that it's gonna be other numbers. It doesn't matter. We just check that. And actually here is just the 2 sum idea. Yeah. If it is inside the dictionary, let me just write a set. Let's just use this dictionary. We will ignore this formula first, and I will add it later. So if it is inside the set, I'm gonna update the result. So the result is gonna equal to the answer, and again I'm gonna break it. And after that, for the hash table, we're gonna prepare this new number, and we're gonna record a value. The value is gonna be n. Yeah, because this is the real value, and this new n is just a temporary value. Yeah, and for us, we need to check the new value. But how can we check it? We're gonna use the formula. So add d with this new number more than and equal to n. It's gonna be, yeah, this one gonna be 2 times x. This is 2 times x. 2 times this number is more than and equal to n. Basically, we're gonna record the result. If it didn't meet the condition, we just put it inside of the head table. And for this new number, we put it as k inside the head table, and we're gonna record the result. It's gonna be this number. Yeah. Now, finally, we're gonna return the final result. Yeah, but before testing, let me just check if there's anything wrong, because it's really easy to make mistakes. So I'm gonna check 20 bits. This is the mask. I'm gonna check the answer. This is just a temporary answer, and for each of the possible results, it's gonna be the result or this bit, because I'm gonna check the bit one by one. This is just for combining all the possible results, and the result is also updated with this answer. I'm gonna check each of the nums, and then I'm gonna update this new number. I'm gonna use the n add a mask. So if this new number bitwise OR, this is basically 2 sum inside of the hash table, and 2 times with this b with this new number gonna be more than or equal to the current number. So this means that it's possible. We're gonna record the result, and we're gonna break it. We're gonna break the for loop, and we're gonna continue to check. Yeah, basically the time complexity gonna be 20 times n gonna be this number. Now let me just run it to check if it works. Yeah, so what is wrong? I don't know. Let me just remove this one and continue to check. Yeah, basically here is okay, but after I used this one, it is not okay. And 2 times this hash table. Oh, it is not this new one. It should be on this one. It should be this new number. XOR is the answer. It's gonna always, if it is inside, then we're gonna use it. Yeah, because I'm gonna check this a new number and gonna XOR this answer. Yeah, if it is inside the hash table, this is basically the 2 sum. Yeah, this means I've already found something like yeah, because for this bit it is 1. It means something I find is 0 1 or 1 0. I find it, so I'm gonna record it. Yeah. So this is why here I'm gonna use XOR. It is inside the hash table, and 2 times this number is still more than or equal to n. Basically, it meets this formula. I'm gonna record the final result. Now let me just submit it and run it. It didn't work for this testing case. So it's gonna be 0, but our output is 2. So what is wrong? Because I forget to sort the nums. Yeah, because if we were to use the formula as I said before, we have to sort the nums first. Yeah, so let's just sort the nums. After sorting the nums, then we can use this kind of formula. Otherwise, how can we use it? Yeah, because for this formula, we have to sort it. This means that the value of x is gonna always be less than or equal to the value of y. And for our checking, for this number, this is always y. This n is always y, and this number is, and d this number is always x. Yeah, so this means we have to sort it before using this formula. Now let me just sort it. Now as you can see it works. Now let me just submit it to check if it can pass. As you can see, it passed for all testing cases and it's pretty fast. And as I said before, the time complexity is n times k. K is 20. N is the length of the array nums. I think that's all about it. Thanks for watching. See you next time.